Pydantic AI's mechanism for conditionally exposing function tools at runtime, governed by a prepare hook that inspects the current dependency state, determines whether a tool reaches the model on any given step. The code below demonstrates this by gating a single tool behind a dependency check that either yields the tool definition or suppresses it entirely. The agent runs twice with different dependency values, producing two distinct outcomes without any model interaction in between. An async prepare function receives the current run context and a pre-built tool definition, returning either the definition or none to control visibility, while the tool itself is registered with ctx.deps available as its first parameter. The two run sync calls, each passing a different integer through deps, show the hook in action. One step where the tool is absent and the model responds with plain text, and another where the tool is present and gets called. From Pydantic AI import agent, run context, tool definition. Agent test. Async def only of 42. ctx, run context int tool def, tool definition. Tool definition none. If ctx, deps equals 42. Return tool def. At agent, tool prepare equals only of 42. Def hitchhiker text, run context int answer, str. Return f text, deps answer. Result equals agent, run sync to sting, deps equals 41. Print result, output. Success no tool calls. Result equals agent, run sync to sting, deps equals 42. Print result, output. Hitchhiker, 42. The prepare hook on an agent tool gates tool visibility per run step based on ctx.deps. When deps is 42, the hook returns the tool definition and the model can call hitchhiker. But when deps is 41, it returns none, and the tool is omitted from that step entirely. This is the core mechanism for dynamic tool filtering. The hook receives both the run context and the pre-built tool definition, then decides whether to surface it. The trade-off is runtime flexibility versus predictability. You lose the ability to guarantee a tool is always available, which can make LLM behavior harder to reason about, but it lets you scope tools to specific dependency states without spinning up separate agents. The guard clause is simple here, but scales to richer logic. You could mutate the tool definition, not just gate it. Let's break it down. From Pydantic AI import agent, run context, tool definition. Imports 3 Pydantic AI framework classes. Agent as the central agent class, run context for passing context into tools and hooks, and tool definition for defining tools with name, description, and parameter schema. Agent test. Creates an agent instance initialized with the string test and assigns it to the variable agent. Async def only of 42. ctx, run context int tool def, tool definition. Tool definition none. If ctx, deps equals 42. Return tool def. Conditionally returns a tool definition only when the run context's dependency value equals 42, otherwise returns nothing. At agent, tool prepare equals only of 42. Def hitchhiker text, run context int answer, str. Return f text, deps answer. Registers a tool named hitchhiker that accepts a run context typed with int dependencies and an answer string, returning the deps value concatenated with the answer. The prepare parameter passes only a 42 to condition when the tool is prepared. Result equals agent, run sync to sting, deps equals 41. Print result, output. Success no tool calls. Invokes the agent synchronously with the prompt testing, and dependency value 41, storing the result. Prints the output field of that result, which is success no tool calls, indicating the agent responded directly without calling any tools. Result equals agent, run sync to sting. Deps equals 42. Invokes the agent's synchronous run method with prompt testing, and passes 42 as the deps argument, blocking until the agent finishes and returning the result. Print result, output. Hitchhiker, 42 prints the output field from a result object. The printed value is a JSON string representing an object with key hitchhiker mapped to 42 The prepare hook and the tool's ctx. Deps parameter are two sides of the same dependency-driven coin. The hook gates visibility at the model layer. Returning none when deps isn't 42 means the tool never reaches the model, so the agent falls back to plain text. When deps is 42, the hook surfaces the tool definition. The model calls hitchhiker and ctx. Deps inside the tool resolves to that same 42 so the tool can act on it. 2 runs, 1 deps value, 2 completely different agent behaviors without any model-level intervention in between. The trade-off is straightforward. You gain per-step flexibility to scope tools to specific dependency states, but you lose the guarantee that a tool is always available, which makes LLM behavior harder to reason about. The guard clause is minimal here, but the pattern scales. Same hook infrastructure, richer conditions, or even mutating the tool definition instead of just gating it.
The prepare hook whispers the hitchhiker tool into being only when deps remembers the number 40.